This is Abscissa, and today we'll be learning how to solve radical equations with extraneous solutions. Your first question probably is, what is a radical equation? A radical equation is any equation that contains a variable in the radicand or under the radical. As you can see in all of our examples, the variable, or x in this case, is underneath the radical. Now, what does extraneous mean? An extraneous solution is a solution that does not satisfy the original equation. For example, when we solve the square root of x equal to -5, x equals 25, but the square root of 25 does not equal -5. It's best to keep in mind that a radical can be a square root or a cube root or so on and so forth. Also, you can make extraneous solutions for many different types of equations. Parts of a radical equation. There are a few parts of a radical equation that you will need to understand to be able to successfully solve them. First, and the most conspicuous, is the radical symbol. It denotes or indicates that the nth root is being taken of whatever it is enveloping. The index tells you what root you are taking. The radicand, which is just a variable in this general equation, is the expression inside or under the radical symbol. All of these parts make up a radical. Any other number, like 5 or 57, not included underneath the radical symbol, can be considered a constant. Though I've written it here, usually square roots don't have their indices written. It is just understood to be 2 if nothing is there. In addition, though there isn't one in this example, radicals can have coefficients, values that are multiplied by the radical. Taking the root? What does it mean to take the root of something? In base terms, to take the root of a number is to find a value that, when multiplied by itself, results in the original number. For example, 2 times 2 times 2 times 2 times 2 times 2 equals 64. So, 64 to the 6th root equals 2. Keep in mind, these answers won't always be clear-cut. They could be decimals or simplified roots. Now that we know all about radical equations, let's get into the first problem. Step 1. Isolate the radical with the variable in the radicand. Step 2. Perform the inverse operation of the square root to both sides of the equation to get rid of the radical. This frees up the x. Now always remember to square both sides or the equation will be uneven and you'll get the wrong answer. Step 3. With the radical gone, you can simply subtract 6 from both sides to get x alone. Voila! Your answer is x equals 3. Now that we've got our answer, we can plug it back into the equation to see if it works. In our case, we plug 3, our answer, back into the equation in place for x, since x equals 3. And we solve the equation. The square root of 9 does equal 3, so it is not an extraneous solution. Problem 2. Step 1. Isolate the radical with a variable in the radicand. This time, the radical is not alone because we are adding 2 to it. All we have to do to get rid of this 2 is subtract it from both sides, like we would from any other linear equation. Step 2. Now, just like we did in problem 1, we want to perform the inverse operation of the square root to both sides of the equation to get rid of the radical. So we want to square both sides. Then, step 3, subtract 9 from both sides. And then finally, step 4, divide both sides of the equation by 2 to get x alone. This makes our answer to the equation x equals 1/2. Now we can plug 1/2 back into the equation in place of x. Since 5 is equal to 5, 1/2 does satisfy the equation, and 1/2 is not an extraneous solution. Problem 3. Step 1. Isolate the radical with a variable in the radicand. As you can immediately tell, this equation is different from the previous ones. This time, there are 2 radicals, and they both contain a variable. In this case, we want to isolate one of the variables, getting it alone on one side of the equation. This simultaneously makes the other radical with the other variable alone on its side of the equation. This way, when we perform the inverse operation, we are simultaneously clearing both of the radicals. If we were to bring both radicals to one side of the equation, and then perform the inverse operation, we'd be making the equation much harder than it would need to be by creating a binomial. Long story short, don't do that. As you can see, we also have a coefficient of 4, which we can't forget to square. Once we clear up the radicals, let's not forget to multiply 16 times 2x. Then we can isolate x by subtracting 6x from both sides. This will leave us with 26x equals 7. So step 4, we divide 7 by 26 to get x alone completely. Therefore, our answer is x equals 7 over 26. Let's plug in 7 over 26 in place of x and see what we get. Since the square root of 112 over 13 is equal to the square root of 112 over 13, 7/26 is not an extraneous solution. Problem 4. Step 1. Isolate the radical with a variable in the radicand. This time, only one radical has a variable in the radicand. This makes things pretty easy for us, since all we have to do is add it over. Something you may not have caught is that we're dealing with a cube root this time. Regardless, our way of solving the equation stays the same. Step 2. Perform the inverse operation of the cube root to both sides of the equation to get rid of the radicals. Then all we have to do is isolate x by adding 3 to 144 and then dividing 147 by 3. This makes x equals 49. When we plug 49 back into the equation, we get 0 equals 0. So, the equation is not extraneous. The last problem we'll be doing today is problem 5. Step 1. Isolate the radical with the variable in the radicand. You might have noticed that there's another variable that's not under a radicand. We only have to isolate the variable underneath the radicand. We do not need to isolate the lone variable. Step 2. Perform the inverse operation. Step 3. Use the FOIL method to square x minus 10. Remember, we create a binomial by squaring the terms on the right. Do not just square the first term and the last term, as it will give you the wrong answer. In place of factoring, you can always use the shortcut x squared plus 2xa plus a squared. But for the most part, if you're in algebra, you'll likely just want to stick to the FOIL method. Step 4. Set the equation equal to 0 by moving all terms to one side. Step 5. Use your preferred method to solve the trinomial. You can try to factor, use polysolve, or you can just use the quadratic equation. Here are your answers in their simplified forms. If you want them in their decimal forms, you can do that. Either way, here's your answer. Now let's again check if they're extraneous by plugging them back into the equation. Don't forget to plug in both variations. In this case, it looked like the positive version of our answer was a real answer, while the negative one was extraneous. Finally, here are some things to remember. Exponents are the inverses of roots. To essentially undo a root, raise it to the power of the index. Always check your answers. Extraneous solutions are real. Use the FOIL method on binomials. Don't just square each term. And we both made it to the end of this video. Thank you so much for watching, and good luck with all the math. Maybe subscribe?